So welcome to 4Keys Private Tuition 4Keys College of Science Education Quadratics. It's G procedure from the previous video that we did, and in this particular video we are going to show other than just showing you my quadratics charadzana futi anonzi ma fractional equations, how you treat them. Sakachata algebra dzese ma fractional equations. In the previous video I derived the quadratic formula, and there's an operation that I applied which you must know about. Some of you came to my inbox and said you might want to explain here, so I'm going to go a step further and show you anonzima fractional equations nekuti matita sei handiti. Saka pane patikapfuura napo panapa apa patikati isusu apa pandakasvika panapa apa kuti kuzoti c over a times 4 over a and try to make this a single fraction. We are trying to combine these two constants kuti iite a single fraction. So what I can do, if you don't understand saying times 4a over 4a, then you can just do it this way. Unogona kungoti iwe unofunga kuti 4a squared na a, what is the common denominator? Ndingaita kuti what is the lowest common multiple? 4a squared na a. Saka toona isusu ari 4a squared nekuti a anopinda muna 4a squared uye 4a squared anopinda futi muna 4a squared. Saka ndoisa lowest common multiple yangu, which becomes the common denominator here. And then operation yandakaita ndeyekuzoti isusu 4a squared into 4a squared anopinda ka 1 to multiply ne this numerator negative b squared. So 1 times negative b squared wawana negative b squared wako, then ozoti a uyu into 4a squared uyu unaona kuti anopinda ka 4a wa multiply na c uyu plus c plus 4ac. Saka ndokusvika kwatikaita apa. But anyway, let's rush to the rules that we are applying. Where are we getting this from? So let's go and see some more. Saka, you must know how to treat some fractional equations. So let's look at some operations that you're supposed to do. Addition of fractions, here we have a over b plus c over d. If you want to combine that into a single fraction, what you can simply do here is you find the lowest common multiple, which becomes a common denominator here. Saka tanchiti sezvananchimweta apa tikati b into bd. How did we get bd? We simply multiply b and d, and it will run a bd. Saka takuchidivide manje b into bd, you're going to get vana b vachakancelana, anditika. So you're going to be left with a d. D will multiply na a. This is how you do it. So that way I get ad. And then ndochizoti d uyu into bd uyu vanopinda kangani? Vanokancelana vanana d ndosarwa na b. B ndobva ndamultiply na c uyu ndinobva ndawana bc wangu. So this is how you would combine this into a single fraction. Ukana yakadai lowest common multiple yangu, it would be the multiplication of this term and also this term. So I should multiply those two. C plus d multiplied by g plus h, and then c plus d into this c plus d, they are going to cancel each other out, and I'll be left with g plus h. Remember, I have to multiply that with the numerator. So g plus h multiplied by what? A plus b. This is what I get, a plus b multiplied by g plus h. And then I do the same here, g plus h into this g plus h cancelana, and I'll be left with c plus d multiplied by this e plus f. This is how I get to this stage. And I can expand the numerator there, collect like terms, and simplify even further. So you can expand and see whether you can rearrange and refactorize, but I think for this one we can end there. Saka ndoma operations atinoita iwawo. Subtraction yakangofanana, we only have a negative sign here, similar to what we did there. So you are going to get this. If I have this situation here, I can simply do the same. The lowest common multiple would be b times e, be, and it can. So I say b into be, I'll be left with e times a. I'm going to get ae. I do e into be, b multiplied by c plus d. So this is what I end up having. So we can expand here and try to collect like terms. So basically this is what we did. There's also another, you can try this yourself. So there's another unique situation that we also came across in the previous video where I said pane quadratic equation yatakatry kusolve using the graphical method tikazoiti has no solution or has no real roots. What does that mean? So we want to look at that situation. Okay, so let's look at this example here. Kana quadratic equation ichinzi haina real roots. We want to show this on a graph. So let's look at this equation. Once we will draw a graph for this equation. So you do your substitution, which is the first part, so that you find your y values. And so you can check whether you're going to get similar values as mine here. You can do it separately. You substitute those into the equation that we have. The 2x squared minus 7x plus 7. And right. Then when up a graph pack or what you plot are those points. So if you plot those points, you're going to realize that. So let's do it together. The first point there would be your -1 and 16, then -0.5. It's important for you to check this on your graph paper. And 11, then 0 and 7, then on and on, 2 and 1, 3 and 4, and then you connect those with a smooth curve. So ukatarisa apo, this curve does not cut through the x-axis. So what does this tell us? It tells us that there is no value, there is no x value that satisfies this equation. 2x squared minus 7x plus 7 is equal to 0, meaning that it has no real roots. So those are not ever gonna cheat, no real roots. So let's also look at another interesting concept come across quadratic equations. Let's look at this question. Given the equation y is equal to -half x squared minus 4x minus 8, complete the following table. So our y values, you simply substitute as we were doing and you get your y values. And B says, using the above table, draw the graph of -half x squared. So in other words, plot it on a graph. So if you did that correctly, unofana kudistributa space yako zvine ungwaru pa graph apo, checking your maximum value and your minimum value. Your maximum value and your minimum value, or distribute a space yako wisely. All right, but if you were to plot that, you would get a graph that looks like that: -6 and 2, -4 and 0, -2 and 2, 0 and -8, 2 and -18. You join with a smooth curve. But part C is interesting here. It says, using the graph in B, solve the equation x squared plus 6x plus 4 is equal to 0. So how do we go about it? So what we need to do is we need to make these equations similar. And we need to try to turn this equation into this equation. How do you do that? So let's look at each term separately. X squared here, the coefficient of x squared is 1, but here it's half. So to turn a 1 into a minus 1 over 2, I simply have to multiply by -1 over 2, and I have to do that throughout the entire equation. And if I do that, here is what I come up with: -1 over 2. So I have successfully turned this coefficient of x squared into this. So it's now similar, but here now I have -3x minus 2. So I have to change this into this. So how do you turn -3x into -4x? You simply say -3x minus x. So you're going to get -4x, and you do the same this side where there's a 0. So you get to this stage, and now I have my -4x, but this is equal to -x. And now how do I change this -2 into -8? If I say -2 minus 6, I'm going to get -8. So I get to this stage where I subtract 6 both sides, and I'm going to get this. So I now have a new equation here that says y is equal to -x minus 6, and I have to plot this on the graph, on the same graph. So I have to imagine 2 points because it's going to be a straight line. So I just need 2 points and connect those 2 points. So when x is equal to 0, I have, according to this equation, my y is going to be -6. When my y is equal to 0, my x is equal to -6, and I can plot that. Graph and connect those 2 points. So the solution is going to be where these 2 lines meet. Okay, this is where the solution is. So if you do that and carefully check, you're going to find that the first solution is -5,2, and the second one is -0.75. So this is how you would manipulate the graph of another equation to solve another equation. So I'll meet you in the next video.